All right, here we're given some data about Big Mountain Community College. We know that in 2007 they had 3,958 students, and in 2013 they had 4,384 students. What we're being asked to do is to find a linear model for this data. And what that means, we're looking for an equation. We'll use E for enrollment. We're going to estimate the enrollment based on a number of years. If we're looking for a linear model, it's going to have this form right here, where m is our slope and b is our y-intercept. A better way of talking about m in this context is the rate of change. Take another quick look at what we're being asked to do here. We're given two pieces of information, and we consider these points on a graph. That in 2013, we had 4,384 students, and in 2007, we had 3,958 students. And we're being asked to construct this model which will estimate the number of students in future years. Let's go about doing this work. Let's find m first. To find this rate of change, in this case it's going to be students per year. What we need to find are the average number of students that are coming to this college per year, in this case part-time students. To do that, we just subtract the number of students to find the difference in the number of students per year. And we subtract the years to find out how many years it took to get this number of students. In this case, what we get is in 6 years, we had a difference of, let's do this calculation here, 4,384 minus 3,958. That gives us 426 students. So what that means is in the 6-year span between 2007 and 2013, we gained 426 more students. And then if we divide these two, we get 71, which means on average we get 71 more students per year. So again, this is students per year. This is called the unit rate for this situation right here. For our linear model, that's what this m value is 71. So this is 71 students per year. Now, another important thing when we're finding linear models, in this case, so E is going to represent the enrollment. X, we're not going to talk about years. X is going to represent years after 2000. That actually wasn't important in the first step, but it's going to be very important in this step. Meaning down here, we're not going to put 2007. Instead, we're going to put 7 for 2007, and we're going to put 13 for 2013. So I'm going to take these two values, pieces of data right here, and rewrite them with this representation. So in 2007, we have 3,958 students. And in 2013, we have 4,384 students. What we're going to do with this information now, we're going to use one of these two data points to find this b value. That's all we need to find right now is the b value here. And what we're going to do is plug in either one of these situations into this equation as it sits right now. So I have E, which is my enrollment. I'm going to plug in 3,958 into that, equals 71 times the year, which in this case is 7. Now again, that's not 2007, it's just 7. And then plus this b value right here. And then we're going to solve for this. So first thing I need to do is figure out what 71 times 7 is. That's 497. And then I'm going to solve this for that b by subtracting 497 from 3,958. So 3,958 minus 497 gives us 3,461. All right, so now we have our whole linear model. In this case, this b value right here is this 3,461. And so this right here is now our linear model for this situation. What this represents is 71 is a number of students per year that enroll at the school. It's a positive value, meaning the enrollment is going up. This b value, this 3,461, is our y-intercept. And what that means is that gives us a third point if we wanted. We have 0, 3, 4, 6, 1. And what that represents in this context, if you're wondering, is that in the year 2000, because that's 0 years after 2000, the estimated enrollment was 3,461. But this right here is our linear model for this data.